we're moving on to our next session. Simona, thank you for kindly staying on and moderating this next session with Stefano, Mintchev, and myself, who will be spotlighted. Here we go. And we can probably let Dr. Yerger go as well to keep him off the hook. Yes, so thank you. So, Simona, back to you if that's okay.
Yes, actually, I didn't remember it was that fast. Okay. Okay, well, I think what I have to do now is to introduce myself and then introduce the session and then move on. All right, so I am, as you know, Simona Aracri. I am a physical oceanographer and a marine engineer and naval architecture. I am a tenured researcher at the National Research Council of Italy, and what our group works on is on marine robotics. We are fond of extreme challenges like glaciers, polar regions, transitional waters, and alpine lakes. And my work in particular is dedicated to render all these expeditions valuable from the data point of view. So what we do is we liaise all together to create at the end a robot that is going to deliver valuable data at the end of every mission. I don't want to spoil too much of what we do because later on my colleague is going to be giving a talk, so I don't want to spoil his part either. Anyway, this is us in a nutshell, and please, if you're interested, get in touch and look for us online. Anyway, in this session, I would like to invite first Patrick and Stefano to introduce themselves, and then we'll move forward.
Sure, thank you. And just to say for everyone, we're going to, Simona's just as much a moderator as well as an active panelist and an expert on these topics. So questions will be for everyone for us to get all the most out of this. But I already briefly introduced myself. Just to maybe quickly say I am the founder of the Climate Robotics Network. I previously served as the strategy lead for robotics at EPFL, the Swiss Institute of Technology in Lausanne. And before that, I co-founded and led an international technology nonprofit called We Robotics. And the focus there was really to enable local experts to be the ones who are in the driver's seat to applying these robotic solutions for positive social impact. So that's me. Over to you, Stefano.
Yeah. Okay. Hello, everybody. Good morning or good afternoon, depending on where you are. My name is Stefano Mintchev. I'm assistant professor of environmental robotics at ETH Zurich. It's really a great pleasure to be here at this second edition of the Climate Robotics Summit. So thanks a lot to all the participants, also to the organizer that made this possible. Very briefly, what we're doing in my lab, where we're mostly studying methods to use robots that help us to better monitor biotic and abiotic factors on our planet at relevant ecological scales, and possibly use this data to better support sustainable development and better understand the effect of climate change and also potentially biodiversity loss. And specifically, we are active in aerial robots. You've seen before many examples of amazing robots that explore the ocean. We like to explore forest canopies and rainforest, where we use our drones mostly to collect environmental DNA to monitor biodiversity. And we do this in a very we use a very much a co-design approach together with biologists, ecologists, but also relevant stakeholders from companies and also local indigenous communities that we involve in the design and in deployment of these solutions. So that was my short introduction.
Great. Thank you very much. So just to give an overview to everybody, this session is entitled The State of Climate Robotics. So we're going to discuss where we are now. And we thought this was going to be a great base to start discussing the state of the art and then move forward and explore the capabilities and the future avenues for developing climate robotics. So my first question for everybody is, what are the most promising areas where climate robotics is already making measurable impact, particularly in the marine and aerial sector? Whoever wants to go
I've been talking too much, so maybe the two of you can do it.
Okay, so then I can go maybe. I think there are several very interesting and impactful application of climate robotics, and we see this by the very rich agenda that we have this year. If I would have to pick one that I would like to highlight, in my opinion, is application of robotics to the to food security and also food production, agriculture in general. I think that it's really interesting because this is a sector where we see robots that see and also do, in the sense that we see a lot of this use of aerial robots that can help us to identify stress in plants at the very early stage, and then the use also of robots to perform very targeted treatment, like for example, weed removal with laser or mechanical system that are also more sustainable and can help us to move towards more organic production system. Yeah, so this would be an interesting, I think, sector to that we see a lot of development in the past years.
So for me, well, of course, I'm more waterborne. So like everything that I know and I work with is related to the ocean. So I think that one great advancement that we have is the fact that we can send robots in dangerous zones, as we saw with Dana's talk in exploration. Like there is less danger for human beings and for personnel. So we can gather data, even if it's not as extreme as the Titanic discovery, but it's gather data in patches of the ocean where normally we cannot gather any observation. But with robotics, we can do it safeguarding human life. Another important thing, as we saw with the Argo floats before, is that we can have diffused observation, diffused data, like all synoptically taken, and we have a good snapshot of what's going on in our planet, at least in the ocean at the moment. So that's a great source of data, a great source of knowledge, and also is reducing the carbon footprint of science as we know it. So it's really a new level of observing the planet that we live on. A third point would be like the safeguard of the ocean itself. So like climate robotics at the moment, and not only the technologies at the moment, if you imagine now what we can do with a long track satellite data, like can allow us to track, for example, poaching in the middle of the ocean. The high seas are very difficult to patrol, as we know, but there are algorithms at the moment developed that allow us to like identify transshipping, for example, in the middle of the ocean, which is something that wouldn't be able to do like 15 years ago. So this would be like my 3 points answer. All right.
Thank you. Definitely cannot. Yeah, that's very well said, and far more eloquently than I would have been able to put it. And just to piggyback, I liked how Stefano, you mentioned, you've got the data collection in terms of use cases, and then you've got kind of the physical interaction that is becoming more and more possible with robotics and marine robotics. And maybe a few examples worth sharing, and I posted again a bunch of links in the chat here. But like Neptune Robotics, for example, what they do, it's basically a vacuum cleaner for the outside hulls of ships. So it cleans the ships, because a lot of stuff starts sticking to ships after months and years out in the ocean, which creates more drag, which means the ships have to use more energy in order to move, obviously. And basically, this is a Roomba for the outdoor external sites of the hulls, which I think is really cool. Then you have this another group, IADYS, a French group that's using floating ocean robotics to collect waste, for waste management, to collect waste. And so it's cool to see how robotics is being used both for data collection, which is like the main use case still right now, and that we're seeing now some other interesting applications as well.
Okay, so also by reading the questions in the chat, I think that our next point is going to be on spot. So we wanted to discuss how are data-driven approaches enhancing the capabilities and value of robotic platforms in climate monitoring and mitigation. So do you want to start, though? I can start.
Right, Simona, if you want. Then I take over.
Okay, so obviously I am close to this problem. We deal with it on a daily basis. The thing is that using a data-driven approach benefits both whoever needs the data, so the scientific community that is going to need the data to interpret natural phenomena or to model our world, and is also going to benefit whoever is developing robots. So this is why normally what we do is to keep the data sets coupled, so that in a mission using an unconventional platform, having a coupled data set is fundamental, because having that, you can interpret the data better, so you know what's going on for real, because these are data that are not conventionally taken. And at the same time, you somehow outline what's the performance of the robot, so that whoever is going to develop the next platform or is going to enhance that platform, and we see this happening with Alvin, with Dana was saying, and we do it also in our lab, like there are many versions and many upgrades that go on in our fleet of robots. So like having that data is fundamental to understand whether we are improving or not, and where we need to improve for the robotic platform. For the data, of course, for environmental data, this is why we do it. At the end of the day, the reason why we develop robots for the environment is because we want to observe what we couldn't observe otherwise. So it is important to bear in mind that there are areas in this data-driven approach for marine robotics that are unexplored and underdeveloped. So we are now, in fact, developing new approaches, new vocabularies, shared vocabularies, so that this data can be fair, in a word, so that findable, usable by everybody, and available for the wider scientific community, and not only scientific. So that's my answer.
Okay. Great. Then I had maybe a slightly different perspective. Maybe from my point of view, especially in the last couple of years, I've seen a lot of very promising development in terms of these data-driven approaches for robots, especially in using machine learning and data analysis to improve what are the performance and also the locomotion capabilities of the robots, which is very relevant, especially when we really try to push our robots into the wild to collect better data in terms of enabling better accessibility to environment that have been not studied in the past, but also improving what are their interaction and their also skills to grasp and also to manipulate samples and objects, which again could be relevant for monitoring, but also for automating agricultural tasks. And also another aspect that I found more and more interesting in this data-driven approach for robots is that these machines are becoming more and more able to perform sampling or survey in a more ecologically intelligent way. So by having by modeling kind of the phenomena that we want to study, we can make them sampled more efficiently. Of course, there are many critical aspects of these data-driven approaches, aspect about, of course, the ownership of the data and also all the energy that is involved into training all these machine learning models. So it's promising, but there are, of course, some also aspects of sustainability to keep in mind that I know as a community that you're sensitive to this. We need to always remember and of course think how we can improve on these aspects. But these definitely data-driven approaches are very relevant and promising, and I think that we'll see more and more in the future.
Good stuff. Nothing to add on my side. Thank you both.
Okay. Yeah, actually, Stefano, I wanted to ask you, listening to you, I was thinking that there must be a similar problem in modeling the robot or controlling the robot. Like if you have to collaborate with teams that are not in your lab, like did you encounter this problem of like having to share data, but actually having to map your data on their data because they were called differently or?
Yeah, I mean, absolutely. It's definitely a key aspect of course to keep like the having some sort of a unified framework for the data and also to collaborate. It's probably not as extreme as we see when we have large data sets that involve also environmental data, but definitely it's an aspect to keep in mind.
Thank you. Okay, so my next question is about interdisciplinary collaborations. So in what ways can this kind of collaboration across robotics, climate science, and data science accelerate innovation in this field? I think Patrick, you'd be the best person to answer this first.
I don't mean to be dodging the question, so I won't dodge this one, but I'd love to also hear, Stefano, with the work that you did in the Amazon rainforest. I've gotten to know about some of the aspects of the project, but be curious to also hear from you in terms of, how did you approach it, working on something that is, multidisciplinary. Let's see, on my side, how do I make this short? So actually, maybe I'll use this to promote another session. On Friday, we're going to have a session on ethical dilemmas of climate robotics, and where we're going to be talking more about this, importance of cross multidisciplinary collaboration. And we have a colleague of mine from the UK, Professor Nezra, who comes from the psychology space, works with business students. And we had started a conversation that was fascinating, talking about the role of friction. With robotics, what we're trying to do is we're trying to reduce as much friction as possible, right? Broadly speaking, not even beyond, obviously, climate robotics. And yet that can have inadvertent consequences because a lack of friction can also lead to behavior change, which may not actually be good for the climate. And I hope we'll get into that a bit more in more detail during that session around waste management and the use of robotics around waste management. And if we make it too easy, could that potentially have a negative effect? And that's not something that I would have discovered on my own had I not been talking to somebody who really studies, robot human interaction and psychology and so on. And so without that, I think, you end up designing solutions that may actually create harm. So for me, expanding the number of disciplines and areas of expertise and stakeholders and taking far more of an inclusive, massively multidisciplinary approach is one way to at least ideally do no harm, and then of course maximize impact and long-term sustainable impact. But that's my 2 cents.
Yeah, maybe I have very little to add because it's I have kind of the same idea of Patrick here. I think that this aspect of co-design of co-development in interdisciplinary team is core in my lab, because I think this is the way you can exactly maximize impact. From a robotics perspective is interesting because otherwise you end up developing a technology looking for a problem, which could be a very good academic exercise. But I think that for climate robotics, impact is what really matters in the real world. I think for our colleague ecology and biologists, it's interesting because they can learn about what are the capacity of the robots, and in this way understand that it's possible perhaps to use this new technology to discover new phenomena or to better understand different problem. And by working together, this is also how I think new solution can be developed. So yeah, these are the three aspects. So yeah, co-designing is, I think, a must in for having impact in climate robotics.
I like the idea of co-designing because I mean, it's great to be able to put together different disciplines and actually come together before a platform is completely finished to say, oh, actually, we need this, this, and this. And the robot will need to glide this way and stop here and hover there. And, you know, I think that's particularly important also as a challenge from the engineering perspective. Like, because, okay, something can work, but can it work the way we need it to work? So also that extra work and extra discussion that goes in the design and the planification of a mission is, I think, is one of the greatest growth opportunities that we have in this moment. Anyway, so shall I move on to the next question?
Yeah, fascinating. Just to also say, I know we have maybe about 7 minutes left. There's some interesting questions popping up on the Q&A chat, which I know is yet another window to monitor.
Yeah.
I don't know if you want to have a quick read, leave it for the end.
Okay. All right, then I'll ask you the next question and prepare to answer the Q&A. It's okay? So because that's some long way. Or if you want, okay, what about this? What are the challenges or involving private sector in deploying the solutions, and how far along is their participation?
Oh man. Can I dodge?
You asked for the windows.
That's a tough one. I don't know. Stefano, do you have something to weigh in on that topic?
It's no, I don't have to say a good answers. It's something that we are kind of approaching a bit right now, because we are kind of the students in the lab are making a company and using robots to monitor biodiversity, and we're trying exactly to a bit understand what is the perspective of the private sector on that. So I guess it's a complex question, and I think it goes down to the aspect that how it's possible to value from an economic point of view nature, and that's a bit the aspects that it's I think still a bit open and tricky to find an answer.
Maybe just to quickly add, one of the challenges that I've seen and also we experienced firsthand is sometimes with some private, especially the bigger private sector companies, sometimes these projects that they fund this is maybe not most of the time, right? This is outliers, but sometimes these projects that they fund are more publicity stunts. They're like one-offs, great photos, great videos. And then you start reading it and you're like, wow, this is amazing. And I remember there was one project like that a few years back as I got started in the climate robotics space, and I was trying to map out who's doing what. And I dug in, and then it was complete fluff. It seemed amazing from the outside, but then when you dig in, it's like it was false advertising, frankly. And so I think there's that's just a challenge there. But yeah.
Okay. Well, I would like to move on to this question that John Barley asked. I think it's very interesting that basically in Samudra oceans, they distinguish between science-grade data and operational-grade data. So the latter one is good enough for seaweed farmers to make decisions, but acquired at low cost that prohibits science-grade sensors and the effort of regular calibration. And he says that he foresees a huge opportunity to process low-grade data to gain wide-ranging perspective. So, and he's asking what's our view and what novel data sources have we looked at. So basically, this is a huge question and very interesting also to discuss further. We often face this dilemma, whether we should take low-grade data or scientifically graded data. Normally, of course, for big missions like the polar ones or like the ones where we really need a big planification, we do use the high sensors, like the high quality sensors. So we have to go through all the calibration steps and intercalibrations too. But if we have to do an exploratory mission, sometimes we use the low grade and the low cost, also to, again, to have cost-effective solutions. So sometimes if we manage to calibrate a low-cost sensor on a high-cost sensor, so we can have high-quality data, but with a much lower cost. But I'm very happy to discuss further. John, please reach out and let's discuss this because it's very interesting for us too.
Okay.
Maybe I add something here. I think it's a very interesting question that has also an implication on the type usually of robots that you want to use to collect different type of data. Because, for example, if you think about our work in the rainforest to monitor biodiversity, when we want to collect really high quality data, we need, you know, also quite expensive sensors and also robots. So we can do this, of course, but mostly for scientific purposes. But when instead we want usually to involve local communities, and we're talking about, for example, like stewardship effort or also restoration effort, this is when you know, we can think about having these more operational data, which perhaps have a bit less that are perhaps less accurate or are a bit less resolution, but can be acquired with much simpler and less expensive type of drones or type of platform. So they're both, I think, very, very relevant, and it's important to, I think, select the right type of data and the right type of also of robots, depending on what is the purpose and the scope of the mission.
That's
brilliant. Super question.
Yeah, sorry, Patrick, go ahead.
No, I just love the question and the answers. Thank you. Nothing to add.
I love the idea of what happens when you have to involve local communities. We had this discussion with aquaculture applications too. And it's mad how different the approach to aquaculture management and data is depending on the country. And this is only within the Mediterranean region. So like it's managed completely different. Like, there are different companies managing it, and depending on the company or depending whether there is a research institution behind the management, then there are different sensors in the water and different data coming from it. So that's a real challenge and a hugely interesting area to discuss. Anyway, I think we have only 2 minutes left, so we need to wrap up. If there are any final remarks that we want to do, then we have time. Otherwise, I would thank you both to be part of this session. It was very interesting to talk, and looking forward to the next.